Hello everyone. So let's now talk about the graphs for displacement time, velocity time, acceleration time. For three different situations I'm going to talk to you about it. This is displacement. Yes, actually, let me write it more visible for you. This is displacement time. And imagine that the position doesn't change in a situation that, for example, let's say you are, if this is your origin, you stay 3 meters away from origin, but as the time passes you always stay here, always, and you won't change, so you won't move. So actually your situation is stationary. In such a case, when there is no movement at all, you can say there is no displacement. The position stays the same as the time passes. Let's look at the velocity in this case. The velocity would be, of course, 0. So the velocity is constant and it's 0 actually. Let's look at acceleration. Of course, the acceleration would be also 0 in this case. No acceleration. So now let's look at the situation when there is a change in your position. So there is a movement, there is a displacement, and your dt graph is actually, however, the change in displacement is constant. Look at here. The change in displacement is constant, therefore there is a line. So the slope of dt graph is actually the same. It wouldn't change, it stays the same. The slope is constant, therefore the velocity obviously is constant, right? So if for this vt graph, it would be constant velocity, which this would be the slope of this line, right? And of course the acceleration in this case, as you can see, the slope of this is 0, therefore the acceleration is 0. This is a constant velocity situation, therefore the acceleration is 0, right? There's no change in velocity, yeah? So now you can have a better understanding of the concept of the slope of a line, yeah? So you know why you learn that in math, because this is existing in nature. These are the laws of nature, and now you have a better understanding why you learn math for. Some students always are complaining, why do we learn these things for? Why do we learn this math for analysis for? This is why you learn them, because these are really existing in the nature and you are discovering them and you're learning them. Now let's look at this other situation. Actually, for this situation, I'm going to start with Vt. Imagine a situation when you have a constant, when you have a velocity which is changing, in this case easier, improving, increasing velocity, which the change in velocity is constant. Of course, when the change in velocity is constant, it means your acceleration is constant. Your acceleration always stays the same. And this is the situation where all our problem solvings actually are this. We are solving these situations in kinematics in high school. So as you can see, the acceleration is constant. All those formulas you have learned are about this situation, and the velocity is changing. This is a uniform change in velocity, of course, and you can see that the displacement in this case, let's have a look at displacement in this case. As you can see, the velocity is increasing. I like to show you how the displacement graph would look like in this case. Of course, it cannot be a line anymore because the slope is not the same. The slope is changing. But is the slope increasing? Yes, it's increasing. So first the slope is lower and it increases. so the slope is increasing. As you can see, the slope in here is less, the slope in here is more. Yeah. So now, of course, this kind of movement is increasing the speed, is getting faster. As you can see, for example, let's say in certain period of time, you have this much, at the beginning of the time, you have this much displacement. At a little bit more, at the same period of time, you draw perpendiculars, of course. The amount of your displacement is increasing, and in here, in the same period of time, exactly the same period of time as this one, look, the amount of your displacement is increasing, obviously, big time. And as the time goes, let's say, for example, this period of time, the amount of your displacement actually, let's see how bigger this is compared to this one. So you can easily see that this is getting faster. This is a movement that is getting faster. Now I'd like to tell you something else. First of all, I'd like to ask you, if you understood what I said, please explain it to yourself. Repeat it to yourself, explain it to yourself, and try to practice these explanations. Now, I'd like to tell you something else, actually. This is also very interesting. Look at this displacement time graphs. Of course, this one, as you can see, at the beginning of the movement, let's say this period of time, displacement was small. The same period of time, at a later time, displacement was bigger. Of course, this movement is getting faster, right? So first it was moving little bit in 1 second, then moves more in 1 second. So getting faster. Now let's look at this graph. How do you see this one? In this displacement, in this time interval, in this period of time, so much displacement you had. As the time goes, in the same period of time that you have in here equal to this, the amount of displacement is much less. Yeah. So of course this was going fast and then slows down. So this is slowing down motion. This is a motion slowing down. Slowing down, right? This is getting faster. So these two, as you can see, they look different. So if they show you displacement time and ask you which one is getting faster, which one is getting slower, you can easily say, and you can understand what's going on. So explain this to yourself, repeat it to yourself.